In this video, I'm going to be working on the chain rule, and this is the second part of my derivative series of tutorials. Okay, so again, we're going to be focusing on chain rule, but I'll be brushing up more on the power rule in the beginning. Okay, so let's go ahead and jump right into our first example. Okay, so let's say you're given this function of 5x cubed plus square root of x. Now there's a shortcut I gave you from the first part of the tutorial that whenever you see a square root of x, okay, its derivative, you have to memorize this just like what I mentioned on the first part. Its derivative is always going to be 1 over 2 square root of x, okay? So we just need to memorize that because this will show up a lot in your calculus class exercises. Okay, so let's go ahead and use our power rule. So the power rule is a very simple rule. Okay, so this applies whenever we have this variable x, plain x as the base. Okay, so you can see the exponent 3. This exponent 3 is for this base plain x. In that way, you can use the power rule. So you multiply this 3 to 5, that's 15. That base x raised to 3 minus 1. So it's a 2. And then use the shortcut. Okay, memorize the derivative of square root of x is going to be 1 over 2 square root of x. Okay, if you don't memorize that, it will be a tedious process to get to that 1 over 2 square root of x. All right, let's take example number 2. Now we have this 4 over x to the negative 2. And then again, I'm going to show you this square root of x for almost every exercise. So we remember and memorize this for sure. Okay, so first thing we do is we want to make sure that the variable x, okay, so this variable x is a numerator before we can apply the power rule. Since this variable x in number 2 is in the denominator, so you want to move this up, okay? You want to move this up, and every time you move up a term, you want to make sure that the sign of that negative 2 switches. So 4 is now multiplied to that x, now to the positive 2, plus. Okay, again, the derivative of square root of x is 1 over 2 square root of x. If there's a constant 3, okay, right in front of that square root of x, you don't worry about that. It's just going to be 3 times whatever you memorize right here. So 3 times 1 over 2 square root of x. Simplifying, this is 4x squared plus 3 over 2 square root of x. So this is our derivative. Okay, let's look at our problem number 3. Let's say we have this f of x equals 2/3 x to the 3 halves. Okay, so this one we have a coefficient which is a fraction. We have an exponent of x that's also a fraction. Again, there's this square root of x over here, but there's like over 3, okay, underneath that square root of x. So let's use our power rule. Now check your x. It has to be plain x, and it has to be numerator, okay? So we satisfy those two requirements. So now we can multiply this 3 halves times 2/3 multiplied by x, okay, raised to 3 halves minus 1. So that minus 1 is in the form of minus 2 over 2. And then, okay, if you want to pull out this over 3, that's the same as 1/3. Okay, because that's 1 square root of x over 3. So you can pull out the 1/3 if you want. And then go ahead and get the derivative of square root of x, which is again 1 over 2 square root of x. All right, so this simplified to 1, okay? X raised to 3 halves minus 2 halves is just 1 half minus, okay, 1 over 6 square root of x. Okay, there you go. That's for our 3. How about problem 4? Okay, let's say we have 2 over x to the fifth minus 2 fifths, again, square root of x. We have to move this x to the fifth to our numerator. So now we have 2x to the negative 5 minus 2 fifths, okay? 2 fifths times the derivative of your square root of x, which is 1 over 2 square root of x. Now you can cross these 2 out. And, okay, hold on. Excuse me, I made a mistake here. Let me, sorry about that. Okay, so I'm gonna clear this out because, when I look at the first one is just the rewriting of our 2 over x to the fifth. Okay, so I just move up the x to the fifth, which is now x to the negative 5. So I haven't used the derivative power rule yet. So this is not the f prime of x yet. I'm just gonna rewrite this, okay? And then the next step is the derivative. So the derivative is negative 10 x to the negative 5 minus 1, which is negative 6. And this should have been 2 fifths. Okay, so minus 2 over 5. And the derivative of square root of x is 1 over 2 square root of x. Again, you can cancel the 2's. And this you can move downstairs. So negative 10 over x to the 6 minus 1 over 5 square root of x. Let's see number 5. Suppose we have, okay, let's say you have 4 times 3x plus 5. So we have this constant or multiplier to our quantity 3x plus 5. So two things, you can distribute the 4 if you want. Let's say distribute this 4, got 12x plus 20. Now you get the derivative, which is what? 12, okay? And then this is constant, so the derivative is just 0. Or, okay, if you don't want to distribute the 4, you can also just bring down that constant 4, okay? It's just a constant, so you can just bring it down and then use the power rule for 3x plus 5. The derivative of 3x is 3, and the derivative of 5 is 0. So the derivative of this quantity is just going to be 3. Hence, the final derivative is 12. So you see, we get the same answer. Now for number 6, I'm going to increase the difficulty of this one, okay? I'm going to be using almost the same set of numbers, but I'm going to raise this to the second power. Okay, so this is the beginning of the use of the chain rule, the second rule of derivative. On the first part, we talk about the power rule. Now, the chain rule applies when, okay, so let me show you the difference between the simple power rule and the use of the chain rule. So if this were like 4x squared, you can see the base here is just a plain x, okay? So it's just a plain x. The base is a plain x. This is the exponent. Over here, the same exponent, but the base for that exponent is not a plain x. All right, so there's like a times 3 next to it and then plus 5. So this requires a chain rule. Okay, so using a chain rule is like a shortcut. There are like ways to find the derivative without the chain rule in this case. But I'm gonna show you what a chain rule uh, do, okay, which is like a shortcut. So 4 times 3x plus 5 squared. Okay, let me clear this and start from a cleaner space here. So 4 quantity 3x plus 5 squared. One more time, if this were like 4 and then plain x squared, all I do is use a power rule, okay? Again, because it's a plain x. So what we do is just multiply 4 and 2, which is 8, and then copy that base x, and then 2 minus 1 is 1. Because this is just a plain x. This is no longer plain x. So the chain rule, it's a chain, okay? So chain rule right here. It's a power rule. So the first thing you do, so this is like my informal way to name a chain rule. It's a power rule with one extra step. Okay, so there's one extra step you have to do. So first thing you do is, just like the power rule, you multiply the 2 and 4, which is 8, and then you did copy the base, okay? Like here, you copy the base x. We're gonna copy that base 3x plus 5, and then 2 minus 1 is gonna be 1. That's a power rule. Now, because the base is not a plain x, we have to do this one extra step, which is get the derivative of that base, which is 3, okay, and then you multiply it to the rest of those terms right there. So times 3. That's the one extra step. You get the derivative of that base and then say times that number, okay? Now, the generalized power rule, like for example here, 8x to the 1, you can still apply the chain rule here. But the thing is, what is the derivative of x anyway? It's just going to be 1. So we don't really bother to use the chain rule when the base is just a plain x. Okay? So all that's left here on number 6 is just simplifying, meaning 3 times 8. Okay? So we just multiply the 3 and 8, which is 24, and then 3x plus 5. Okay? So you can leave your answer as is, or you can distribute the 24. All right. So that's the chain rule. And let me give you another example using the chain rule. Suppose we have very similar to that, say 3x minus 2 to the 7th power. So again, go ahead and use the power rule. Okay, but don't forget to do that extra step. Okay. So that's what? 7 times 4 is 28. Copy the base 3x minus 2. 7 minus 1 is 6. And then make sure you get the derivative of the 3x minus 2, which is 3. Okay, and then go ahead and multiply 28 times 3. That is 84 times 3x minus 2 to the 6. Okay, that's the chain rule. Now, number 8, say we have 3x squared plus 5x plus 6 to the 3rd. Okay, so use the chain rule. So 3 times 2 is 6. Copy the base, 3x squared plus 5x plus 6. And then 3 minus 1 is 2. And then multiply this by the derivative of the inside, which is what? 6x plus 5. Okay. Again, the derivative of constant is 0. Right? So this is the derivative using the chain rule. What about the ones that involve square root? Say we have square root of x. Okay, hold on one sec. Say f of x equals square root of x. Again, the derivative of square root of x, I hope you already memorized, is 1 over 2 square root of x. So chain rule applies to something in which the inside of the square root is no longer plain x. Let's say x plus 4, okay? So if the radicand or the term inside the radical is not plain x, let's say there's something else like plus 4. Now you have to use a chain rule, okay? Now the first thing we do is apply what we just memorized, okay? So the structure is going to be like this. So 1 over 2, the square root of that x plus 4. Now this is the one extra step, okay? You get the derivative of this radicand, which is just 1 anyway, because the 4 is constant, its derivative is 0. Okay, so just to make sure that we're consistent, okay, in using the chain rule that involves square root. So we want to make sure to do that extra step. So 1 over 2 square root of x plus 4. Right, let's say we have this square root of 2x. So the derivative again is 1 over 2 square root of 2x, and then multiplied by what? The derivative of the 2x, which is 2. So we use the power rule to find the derivative of the 2x. And then you simplify. So this 2 and 2 will cancel out. So our final derivative is 1 over 2x square root. All right. So let's do one more. Let's say you have a square root of 2x cubed. So the derivative is going to be what? 1 over 2 square root of that 2x cubed. But don't forget, it's no longer plain x, so multiply that by the derivative of 2x cubed, which is what? 6x squared. And then go ahead and simplify. This 6 and 2 is reduced to what? 3x squared over square root of 2x cubed. Okay, one last. This is probably the most complicated among the examples that I showed you. Let's say 4 square root of, say, 2x to the 6. Okay, so the derivative is going to be what? So now there's a 4. So this is constant, so we can just bring it down and then apply what you just memorized involving the square root, okay? Which is what? 1 over 2 square root of 2x6, and then multiplied by what? The derivative of 2x6, which is 12x to the 5th. Okay, so we can start simplifying this 4 and 2, just 2, okay? And then 2 times 12 is going to be 24 x to the 5th over square root of 2x6. Okay, so I hope you memorize the derivative of square root of x. I can just say what is the derivative, what is d by dx of square root of x is just going to be what? 1 over 2 square root of x. Okay, so that will save save your time. Okay, whenever you see this type of problem in your calculus class. Right. So hopefully this part of the tutorial series on derivative help. And thanks for watching. I'll see you again next time.